So we're still in section 9.3, and there is still a video from the author that you can watch that's in My Lab Math. But I also wanted to point out that on page 603, you're going to notice two formulas that look a little different than what he used inside the video. I mentioned in another video that I made that you've got to be fluent, going from complex to rectangular, back to polar, to exponential. You got to know how to get to all of them. So as you look at page 603, notice I have a note to put this on your formula sheet. So hopefully somewhere on your formula sheet you start in a complex area, a complex section, and you need to put these two formulas there because we need to know how to multiply two complex numbers as well as be able to divide two complex numbers. So my suggestion is that you put the product of z sub 1 and z sub 2, and then you put that as what you do to get the product. Here you have the quotient between the two complex numbers. I think you should write this part here on your formula card of what to do when you have a quotient of two complex numbers. So I'm going to work through the bottom of that page at example 4. You already see I've got a whole lot of numbers and stuff going on down there, but I want to point out that right here we have z and we have w, two complex numbers. You need to note that they're written in polar form. That's pretty important because there's your r, there's your theta. There's your r, there's your theta. And it's asking us to multiply them for part A and to divide them for part B. Then right below it, it says, oh yeah, by the way, express the answers in polar form and in exponential form. So when we go to multiply these, it doesn't matter. It doesn't matter which way you go or what you do, because to do polar, you need an r and a theta. To do exponential, you need an r and a theta. The only thing is back up here, it didn't show us how to combine them, like to multiply or divide them, using polar form. It only showed us exponential. When you watch his video, you're going to see polar form, and you may want to take his formulas and write those on your formula card also. I'm going to follow what's in the book, and for example 4, it says leave them in both polar and exponential. So I'm going to start with exponential, since that's what I'm given as far as a method to multiply two complex numbers. So to multiply two complex numbers, z sub 1 and z sub 2, but in my case, I have a z times a w. I'm going to go take their r's, and I'm going to multiply those together right here. And that's going to be times e to the, you see the little I, to the I, and then I need to add their thetas. And I'm done. Well, I may need to simplify and move some stuff around, but pretty much we're done. And so I'm going to go back down here to where we were, and my z times my w, I'm going to take my two r's and multiply them, 3 times 5. So I get 15 on the front. I have e to the I, and now I need to take my pi over 9 and my 5 pi over 9, and I need to add them. So 1 pi over 9 plus 5 pi over 9, I get 6 pi, look at that. I hate it when I do that. That's a pi over 9. That is not. That is a 5 pi over 9. That is. That is my brain. Let's go on to the answer. We're not there yet. How about pi over 9 plus 5 pi over 9? And when you add the numerators, you get 6 pi over 9, which can reduce by taking out a 3 from the top and a 3 from the bottom. And we are done, except I want to show you how they write it. You see how they write it kind of sideways? It's okay, but I prefer that we write it like this. I'm not going to count off, but I just think it looks better. So remember how I said you got to be fluid? What do I have? Where am I going? What do I need? And when I look at the start of these, they're in polar. It says it wants the answer in polar or exponential. I needed to start with exponential because that way it'll get me the product and the sum, which that's what he's going to show you on the video, but he shows it to you using polar form. And then they also want this in polar form. And so got the z times w. I'm just going to make a note that this is my r and this is my theta. If I want to go to polar form, I need my r times my cosine of my theta. Oh gosh, look at that. Plus I sine of my theta. I'm going to circle this, and I just want to point out down here at the bottom. Way down here at the bottom, they have exponential and polar forms. It's what we've got. Whoa, I can't get them all on there at the same time. It's what we have. And again, you need to be fluid and being able to go back and forth to be able to do polar, complex, rectangular, and exponential. But wait, there is more. It also asked us to do the product and leave those answers in polar and exponential. So I'm going to go back up here to our formula. And since our formula for the quotient is also an exponential, I'm going to do that we have z complex divided by w complex, and we're supposed to take our r's, sound like a pirate every time I do that, e to the I, and we're going to divide our r's, and we're going to subtract our thetas. So I am going to start again with exponential, because that is what I am given. Sorry, I'm having an issue with my book. I'm trying to find the screen on my document camera. So here we are. And when I go to divide these, I've got z divided by w, so I have 3 divided by 5. And then I have, and I should do, e to the I, and I need to add, subtract. So I'll have pi over 9 minus 5 pi over 9. Pi over 9 minus 5 pi over 9, which gets us a negative 4 pi over 9. That's not going to work. It can't be between, it can't be negative. It's got to be between 0 and 2 pi. And so since it's not, I need to back up. And so when I go to back up, I'm looking around at like, what in the world, what's going on here? And I was looking for a graph, and let's create our own graph. So negative 4 pi over 9 is just under a half. So if I'm going the negative direction, negative 4 pi over 9 is going to land in the 4th quadrant. Can't have it negative, I got to have it positive. So I need to do 2 pi minus my 4 pi over 9. The lazy way here is I've got 18 divided by 9, because 18 divided by 9 gets me my 2 pi, and that puts me at 14 pi over 9. We have a winner, and now I can go back up here and use my 14 pi over 9. But wait, we're not done. It's got to be up here somewhere, right here. Whoops, y'all can't see that. So right here, I have my 3/5 times e to the I to the e to the I times 14 pi over 9. They've already got their polar. I'm going to go ahead and do our polar. Anyway, you'll see how they did it in the book. You can follow theirs and do theirs, or you can follow mine. I kind of think mine's faster. Either way we go, we have an exponential form, and now to get to polar, I need to put my r times my cosine of my theta plus I times sine of my theta. So hopefully we match what they have in the book. It's always exciting when that happens. We have what they have. If I move it this way, I can see it better. Anyway, all I'm trying to say is you need to make sure that you have these two formulas, and maybe even the two that he shows you on the video, written on your formula sheet. And you need to know how to manipulate these to actually multiply the complex numbers and divide the complex numbers.